Hello everyone, in this video I will be teaching you how to code by teaching you the foundational building blocks of software development. I find that most people, when they ask me about programming, think that you need to be some kind of genius to become a software developer, and that's far from the truth. I think that if you learn a few key concepts and have basic problem solving skills, anyone can become a software developer. If you're new to my channel, my name is Zach Marvin and I make tutorials about software development, game development, and I record my progress on my own game development journey. If that piques your interest, be sure to hit the like button, the subscribe button, and let me know what tutorials you would like to see in the comments below. In today's video, we'll be discussing the following topics. What is programming? How do we write programming? What is high-level code and low-level code? What language should you use? What are variables? What is pseudocode? What are conditional statements? What are arrays and lists? What are loops? What are functions? What is scope? And what are imports? The first question the absolute beginner should ask is, what is programming? Programming is the act of writing very specific instructions in a human-readable language that is then compiled or interpreted into a machine-readable language that tells a PC what to do. Now, these commands must be very specific because a computer has no prior knowledge, no way of getting context clues, and no way of making general assumptions about what you want it to do. So for example, if you wanted to make a program on how to make a peanut butter and jelly sandwich, to tell a human to do that, or an adult human, you could just say, hey, the peanut butter's in the pantry, the bread's in the pantry, the jelly's in the fridge, and the silverware is next to the sink. And the human can use context clues, general assumptions, and prior knowledge to make a peanut butter and jelly sandwich. A computer, on the other hand, is much like a toddler that actually listens to your instructions. You have to give very detailed instructions and the computer will be able to make your peanut butter and jelly sandwich. Your code can get messy and really long, really fast, and it can be hard to remember where your code is and what code is talking to what. That's where IDEs come into play. An IDE is an integrated developer environment, and you can think of IDEs kind of like Microsoft Word for software developers. If you're an author and you needed to write a 300-page book, you wouldn't just open up sticky notes and Notepad and start typing. Because you're not going to have autocorrect, you're not going to have formatting, you're not going to have all the additional tools that something like Microsoft Word would give you. That's where IDEs come into play for software developers. They give you a similar set of tools that allow you to easily debug, track your code, and understand where the bugs are going to be before you even run your code. There are tons of IDEs out there, but I strongly recommend Visual Studio Code. It's free and it supports hundreds of software languages. That's right, I said there are hundreds. Actually, there are over 8,000 software languages. So now you may be thinking, well, what language do I choose? You don't got to worry about 8,000 software languages. I would say 99% of code is probably done in the top 25 software languages. But before I get into what types of software are used for what types of applications, let's make a general distinction between software languages. There are high-level languages and low-level languages. High-level languages are much more human readable, easier to debug, easier to read in general, and they're just more abstracted from machine code. Whereas low-level languages are much harder to read, but they're much more memory efficient, and it's easier to translate them into ones and zeros for machine code. Most high-level languages require you to compile or interpret them before they can even be read by a machine in ones and zeros. So now that we know what high-level and low-level software languages are, and we know that different software applications use different software languages, let's go over some of the basic types of software applications and their most common languages. So if you wanted to build a Windows application, I would highly recommend you learning C, C++, C#, or Visual Basic. If you want to build a Linux application, you would likely want to learn C. If you want to build software for Apple devices, you could use Objective-C or Swift, but I highly recommend Swift. If you're interested in making software for Android devices, you have the option of using Java or Kotlin. For web development, which is arguably the most common type of development that most developers start learning, you would want to learn HTML, CSS, and JavaScript. Eventually down the road, you might also want to learn TypeScript. If you're doing database development, you will likely need to know SQL, which stands for Scripted Query Language. Lastly, if you want to do some form of data analysis or visualization, I highly recommend that you use Python. Lucky for you, whichever language you choose and whichever type of software application you're trying to build, this video and this series will still apply to you because I'll be using something called pseudocode. Pseudocode literally stands for fake code. It is just a general, more relaxed way of writing code that is easier to understand and easier to read by humans. I will also be showing you every example in a real coding language so you can kind of get an idea of what this would look like in actual code. Before I get into these pseudocode examples, I need to explain the most basic concept in programming, and that is variables. Variables are essentially nicknames that you give to memory locations on the computer to store data. Think of variables as the little sibling to files. Files store a lot of data and they can be referenced from a name and an extension, and the extension tells you what type of file that is. Variables are very similar to this. They store data and then they have a name or a nickname that you've given that data or that memory location, and instead of using extensions, they have a type keyword that tells the programming language what type of data is being stored at that memory location. One of the most common types of variables is integers, which you can use to store whole numbers that you can do math with. Characters are letters and numbers, but you can't perform math on numbers that are of a type character. Strings are just a sequence of characters. Floats are a lot like integers, but they allow you to store decimal point values. Booleans can only store two possible values, true or false. And you can reserve a name or a nickname for a memory location, but not give it any value using the null keyword. Another key point to note is when it comes to variables, languages are divided into statically typed variable languages and dynamically typed variable languages. What this means is statically typed languages require you to explicitly say the type of a variable when you declare that variable. Whereas dynamically typed languages, you don't have to say the type for the variable, and then the computer will determine the type based off of the information you put in that variable. For example, if you wanted to store a person's name in a variable, it would look like this in a statically typed language. Now, if you wanted to store the same name in a variable in a dynamically typed language, it would look like this. Some common languages that are dynamically typed include Python, PHP, and JavaScript. Some examples of statically typed languages are C, C++, C#, and Java. Another big difference in variables depending on the language is the idea of constant variables. A constant variable allows you to say that this variable will be declared once and never changed again by using a keyword. Different languages use a different keyword to declare constant variables. C++ and JavaScript use the const keyword, while Java uses the final keyword. Swift uses the word let, and Kotlin uses the word val. And Python doesn't even let you set constant variables. One more thing to mention when it comes to variables is that you can lock them down much further using keywords like getter, setter, public, and private. A getter essentially says this variable can be retrieved and read, but it can't be modified. A setter does the opposite. It says this variable can be set, but it cannot be read. The private keyword allows a variable to only be read and modified in a smaller section of code, while the public key variable allows it to be modified and read anywhere. Now that you understand the most fundamental concept of programming, let's talk about how we can manipulate those variables and perform actions based off what those variables equal to make a program. Almost all programming can be broken down into three parts: evaluating a set of criteria, doing something if it was true, and doing something if it was false. In code, we can do this using conditional statements. There are four primary types of conditional statements: the if statement, the else if statement, the else statement, and the switch statement. The if statement is made of three parts: the keyword if, the evaluation criteria, and then a block of code underneath that will run if that evaluation criteria was true. The else if is very similar to the if statement. It has three parts. It has the else if keyword, a criteria that is different than the if statement above it, and then another block of code that would be ran if that else if statement was true. The else statement is kind of like a catch-all statement. It's appended to the end of an if statement or an else if statement, and it's only ran if all the previous statements return false. The switch statement is kind of like an accumulation of the if, else if, and else statement. It is typically thought of as a cleaner way to write conditional statements, and it is usually used on much longer if, else if chains. In a switch statement, you have the switch keyword, the value you want to evaluate, a bunch of cases, which are what you want to compare the value to, and then a default statement, which kind of acts like an else statement, and it runs anything that didn't fall in any of the case statements. You can do a lot more in these conditional statements than just evaluating if one value equals another. Conditional statements use different types of operators to perform different types of evaluations. You have the obvious one, which is the equals operator, which just compares if one value equals another. You have the greater than operator, which compares two numeric values and determines if one is greater than the other. You have the less than operator, which does the opposite. You have the greater than equals operator, which compares two numeric values and determines if one is greater than or equal to the other. And then you have the less than or equals operator, which is the opposite of that. You have the AND operator, which allows you to combine multiple evaluation criteria, and if all of them evaluate true, the block of code below will be ran. You have the OR operator, which will run if only one of the evaluations was true. And you have the exclamation point, which inverts one side of the evaluation. Now that you know what variables are and conditional statements are, let's jump into a slightly more complex topic, and that's arrays. Now, I would highly recommend paying attention to this topic and maybe even doing some more research after this, because from my own experience and from talking to other new developers, this is a common point where developers get hung up and feel really frustrated and defeated when learning about arrays. The technical definition of arrays is a sequence collection of elements of the same data type with a single identifier. In layman's terms, an array is basically just a list with the same type of variable stored in that list. This could be a list of strings, integers, floats, booleans, you name it. As an exercise, let's imagine you have a list of phone numbers written down and you want to store them in a computer program. You would need to declare an array in your program as a variable, with each number being split up by a comma. Arrays can also be two-dimensional. What this means is that you can have arrays within arrays. A good way to visualize this would be to imagine you are tasked with storing the top 5 songs from the top 5 artists of the year. So you have to store 25 songs total, and that's 5 songs coming from each of the top 5 artists. Imagine you had a list of each artist, and then you had a list of their top 5 songs. A 2D array would allow you to store this information like so. Arrays behave very differently from language to language. In some languages, they're called lists, like in Python. In other languages, lists are something totally different. Some languages even have something called array lists. I highly recommend once you decide on a programming language that you want to learn, you study up on arrays for your specific language. Even though arrays vary differently from language to a language, most languages allow you to manipulate arrays in the same common ways. You can add an element to the beginning of an array, you can add an element to the end of an array. You can remove an element from the beginning of an array, you can remove an element from the end of the array. You can resize an array, and you can get a value for a specific point within the array. One thing to keep note of though is that most arrays don't start at a count of 1, they start at the count of 0. So the first element in the array isn't the first element, it's the 0 element. And this is because computer languages are zero-based languages. Now that you understand what arrays are, let's talk about another building block in programming, and this building block lets you loop through the arrays. And if that didn't give you a hint, the next thing we're going to talk about is loops. A loop in programming is a lot like a conditional statement. It evaluates some criteria, and then it runs a block of code. The difference being, it'll then evaluate the criteria again, and if the criteria is still true, it'll keep looping. There are 3 types of loops in programming: the for loop, the for each loop, and the while loop. The for loop will execute a block of code until a value in the evaluation criteria has been incremented enough to satisfy that evaluation criteria. So say we wanted our code to count to 10. It would look something like this. We would have the for keyword, and then count is set to 0. While count is less than 10, add 1 to count, and perform this code below. The for each loop is a lot like the for loop, and in Python, the for loop is actually a for each loop. I know it's confusing, that's why you really need to study the specifics of whichever language you choose. But basically, a for each loop allows you to iterate over a list of objects and return properties based off of the current iteration of the object. So say you had a list of dogs and each dog had a property called collar, and you wanted to find the dog with the red collar. It would look something like this. You would have the for each word, and then you could say for dogs in all the dogs, and then in the block below you could access the dog's collar property for that specific dog on that loop, and then have a conditional statement that says if dog's collar equals red, hooray! It's worth noting that most times you use a for each loop, you could have also accomplished the same thing with just a plain for loop. So in our given example, we could have accomplished the same thing like this. Now the while loop is slightly different. It doesn't increment a certain amount of times, and it doesn't increment through a certain amount of objects. It just has a condition after the while statement. While that condition is true, it will run the block of code below it. So if we wanted to write a program to eat a snack, our while loop could look like while I'm hungry, eat a snack. Loops are a great way to process a lot of information in a short amount of code. Which brings me to my next point. A core principle in programming is to not write the same type of code twice. This is called the dry principle. Do not repeat yourself. The longer a program is doesn't necessarily mean the better that program is. For example, if I wanted to write a program to count to 10, I could do that in 12 lines of code, or I could write a for loop. Another way programmers use the dry principle is to use snippets of code called functions. Functions essentially allow you to reuse the same code and call it based off of a nickname you gave it. You can also pass parameters into a function. Say we want to write a program that can change tires on a car based off of the tire size given and will change all 4 tires. Now this could look really long if we wanted to handle every possible car combination, or we could use a function that allows you to pass in the tire size, and then we could reuse the same function for all different types of cars. We could also throw in a loop to shorten this up a little bit. Functions also allow you to return a variable. A good example of this is, say we wanted to write a program that generates a random color. We could call a function, and then in that function generate a random number, and then maybe we have a switch case based off of the number, we return a specific color. Then we can assign that color to a t-shirt by calling that function. By manipulating variables with functions, loops, and conditional statements, we have a really powerful tool set to create whatever type of program we want to create. But there are a couple other concepts you should know about, and one of those is scope. Scope is basically the concept of what code can access what variables based off where that code is and where the variable was declared. For example, if I have 2 functions and I tried to call a variable that was set in function 2 in function 1, you would get an error because the variable has a local scope of function 2 and function 1 cannot see it. If you needed a variable that could be accessed by both functions, you would just declare that variable outside of those functions. Some languages allow you to get around this using keywords like global. Now you may be thinking to yourself, this is an awful lot of information and I have to write an awful lot of code just to be able to do some simple tasks. Well, lucky for you, programming has been around since the 1840s. Yeah, that's right, programming was invented in the 1840s by Ada Lovelace, but that's a topic for a different video. But since programming has been around for so long and is so prevalent in the 21st century, there are plenty of people that have already written pretty much any type of code you could think of. And a lot of this code is accessible using something called import statements. Import statements allow you to use code that was written by someone else and packaged up in a library and call those functions and variables inside your own code. So for the car example I talked about earlier, say I sat down and wrote a program on how to change a tire, and you wanted to also change a tire on a car. If I packaged my code up in a library and then you imported it into yours, you could then call the functions that we talked about earlier in this video. There are thousands of libraries out there for thousands of languages, so building that dream application of yours isn't really as far-fetched as you think. Now that we've discussed what programming is, how to write code, the differences between high and low level code, the different types of programming and their associated languages, what variables are, what pseudocode is, what conditional statements are, what arrays are, what types of loops are, what functions are, what scope is, and how importing libraries work, I strongly believe that you'll have the basic building blocks and foundational knowledge to start your software development journey on whichever language you choose. Now keep in mind you will have to learn the ins and outs and the specifics for whichever language you choose. If you like this content and you think you learned something from this video, hit that like and subscribe button and let me know what you learned or what type of content you want me to make next. I will soon be posting an in-depth series on how to make video games using software development. If that sounds right up your alley, then you definitely want to subscribe because I'm also posting a devlog series on my upcoming video game and the process to make that video game. Well, that's all for now. My name is Zach Marvin and I will see you in my future videos.